to do, like I said, is just take a moment to check the answers to your warm-up and make sure that you did that correctly. What's up, Ed? So you know, I like that in your question, you know that the first thing you have to do is factor these denominators completely. So when I bring down the item that's on the left to initiate the second step of our process, I have to compare it then with what's on the right. And I have to ask myself, are there any factors missing when I look at this and compare it to what I already have written down? And the answer to that question is yes. There's another factor of x plus 1 that I didn't write, so I have to bring that down. It goes back to that idea, just to throw back to yesterday a little bit, Ed. I think you were even saying this, you know, x plus 1 times x plus 1, you know that that's x plus 1 quantity squared, right? And then this is x plus 1 to the first power. Well, look which one has to be in our answer. It's always that base that has a higher exponent. So you pick the thing that has the largest exponent to be part of your least common multiple. Neglecting to include that other factor of x plus 1 means that you're finding like more of a common factor, not really a common multiple. Questions about that? Nope. Sweet. Okay. Are there any questions on number 3, parts A through D? Everybody's good with adding and subtracting fractions? Okay, so to kick off today's lesson, let me be honest with you. Ready? Full disclosure. The process that you go through when you add fractions with numbers is the exact same process that you go through when you add rational expressions. In other words, when you add fractions that have polynomials in the numerator and denominator. So with that being said, I kind of wanted you to tell me about the process that you went through or that you go through whenever you add or subtract fractions. So I just kind of wanted you to think about that for a second. So what do you do first when you're asked to, like, I gave you that warm-up right there, A through D. You had to do it. I didn't tell you how to do it. You just had to do it. Like, what did you do? Tammy, what did you do first? Where did you look to see if there was a like denominator? Very good. So what we see is there's this case, or there's this set of cases. There's the case where when you go to add fractions, your denominators are the same. And then there's the case where your denominators are different. And you kind of handle the problems in 2 different ways based on that, huh, Tammy? So yeah, Tammy is right. You got to look at the denominators first. So let's handle those cases now a little bit separately. Tammy, you're off the hook for now. You don't have to talk again. We're going to look for other voices. So we're handling the case first where the denominators are the same. What do? You add straight across. Everything? Only the top. Very good, Chris. So, for instance, in part A there, you just add the 3 plus 1 to get 4. The denominator, the like denominator, just comes along for the ride. That's different than what we did before with multiplication and division. The denominator just didn't come along for the ride. You actually had to put them together. Remember that? A little different. Although Chris gave us the next step, we're not quite done. There was indeed something else that we did at the end of, for instance, part A that Chris didn't quite describe just yet. Nicolette, do you see it? Yeah, you have to always make sure your answer's in lowest terms. And to do that, we kind of think about common factors that the numerator and denominator would share. And you reduce out factors of 1. Good job, Nicolette. Okay, good. All right, that was case number 1. Case number 2, the denominators are different. So then what do? So right now I'm referencing, like, what'd you do for B and C? The denominators were different. Do you know, John? Yeah, you find the least common multiple of the two denominators. Very good. Okay, then what? Go ahead, Ed. Yeah, very good. What you do to the denominator, you do to the numerator. So we basically rewrite our fractions. For instance, in part B, we turned 2/5 into 4/10, and 3/10 got to stay the same. You basically have to rewrite your fractions so that they have the common denominator in them. And we follow Eddie's protocol there, where you multiply the top and bottom by the same number. You have to multiply by a factor of 1. And then, what do? Now our denominators are the same. What do we do? Yeah, good, perfect. Okay. You okay with that process? Maybe you didn't speak just now, but everybody's okay with the process? It is the exact same process for when we add rational expressions. So like I'm trying to tell you, I've said it a couple times. I know I'm repeating myself. I sound like a broken record, but the process is exactly the same. So let's do it. Giddy up. Blank note sheet. Okay. Sort of. Pardon me. Trying to find my blank one. There it is. Blank. Okay. Remember that in the back of our minds, we're always thinking about, do we have a common denominator? Are we able to add or subtract yet? You can't do it unless your denominator is the same. So in order to first start our fractions, we always look to see that there's a common denominator, or LCD. So when you look at example 1, my eyeballs immediately go to the denominator. And you see here, the denominators are the same. And when that's true, you're like, yes, it's awesome. Because the process is pretty easy, and Chris outlined it for us. When our denominators are the same, you basically just add straight across. So we're going to do 2x plus 5. And then the denominator just comes along for the ride. So that's over x minus 3. We try to reduce it if we can, like Nicolette pointed out. We try to reduce it if we can, and we can't. So we're done. I have a question for you, though. Just because when we start to review for our test next week, domain is on that test. So I got to talk to you about this real quick. What's that doing there? You know, John? Yeah, you can't divide by 0, so if you let x equal 3, bad things happen, right? X can't be 3. That gets excluded from our domain. So we would have a graph with a vertical asymptote at 3. Okay. This, in a nutshell, let's say you're going through your homework tonight and you're like, oh, I can't remember where to start. These are the steps that you just told me. So these are the steps for adding, rational expressions. We'll walk through them. Step 1, you have to look at the denominators, make sure they're factored, find the LCD. Then you rewrite your fractions so that they have the LCD in them, and then you add straight across the top. Factor and reduce if possible. So let's do it. Those are your steps if you get desperate. So right away my eyes go to the denominators. And I'm like, boo, there's more to it than there was on the previous problem. These denominators are different. So the first thing I do is I factor those denominators in an effort to identify the least common multiple. So x squared plus 3x plus 2. I'm going to factor that. I think about the things that multiply to give me 2 that add to 3. And that's just 2 and 1. So I'm going to replace the trinomial in the denominator with its factored equivalent, x plus 2, x plus 1. And then I have to factor x squared minus 1. That's indeed a difference of 2 perfect squares. That factors to be x plus 1, x minus 1. I then use this to find the LCD. Oh my gosh, I feel like I did this one already today. I think I did. I think it's in your warm-up, right? I think it's the same as question number 1. Deja vu. Is it? No? That was. Yeah, it is. Same one. The LCD I'm finding here is the same as the LCM you did in number 1. See that? Super fun. So you actually already found the LCD here. You brought down the thing that was on the left. And then you compare it with what's on the right here. The only factor I'm missing is the factor of x minus 1. So that's finding my common denominator. We just do the process that we did over the last 2 days. Okay. After you identify your common denominator, we now need to rewrite our fractions so that they have the common denominator in them. So what you'll see here is I have x over x plus 2 and x plus 1. Then, if I look at this, I ask myself, yeah, that's not the common denominator, x plus 2, x plus 1. Something's missing. It's actually missing that factor of x minus 1 when I look at it. So I'm going to incorporate that factor of x minus 1 because the goal in this step is to rewrite the problem so that the denominators are the same. And I'll go ahead and bring down my plus. And then the next fraction was 2x minus 3 over x plus 1x minus 1. I now compare that denominator to my LCD, and I notice that I'm missing that factor of x plus 2 right there. So I'm going to go ahead and incorporate that factor of x plus 2 in my denominator so that I get fractions that indeed do have the same denominator. Usually I'll get a student say, who'll say, but Mrs. Lucas, the parentheses aren't in the same order. And to that I say, does that matter? What do you think, John? Oh, yeah, a different question. Go ahead. Are you looking right here? Right here. Because I put it on the bottom? Uh-huh. We can't just arbitrarily add things to the bottom of the fraction. That's a good question, John. It'd be nice, but that's not the way it works. Here's why. If I put x minus 1 over x minus 1, the numerical value of that ratio is 1. I've essentially multiplied my original fraction by 1. Does multiplying by 1 change anything, John? No. So that's why this is algebraically legit. If I only put it on the bottom, I'm actually changing the numeric value of my problem, and that's no good. I'm not allowed to do that. Where'd she go? Emma, end of the period. Okay. Any other questions about that? No? So John, if you're like having trouble remembering, in the warm-up, you know how you multiply the top and bottom by 3? Same idea. Make sense? Okay. So you see that I had to multiply the top and bottom by x plus 2 on the right? Okay, back to my question. Does the order of these parentheses matter? No, it doesn't. Multiplication's commutative. So right now my denominators are the same. Now, I'm through step 3, last step. I want to add so badly because it's telling me to add, you know? But the problem is on the top I don't have any terms to put together. So what I'm going to go ahead and do is just distribute through the top and FOIL over here. That allows me to get individual little pieces that I can then sum together. So that's what I'm going to go ahead and do. I would distribute my x in, so that's going to give me x squared minus x. Bring down my plus. I'm going to FOIL that second numerator. And now, since I have my common denominators and my numerators are written in terms, I can just combine like terms to add. So, for instance, I see I have 2x squared and x squared. Those are like terms. I can put those together. I also have x, negative x. Those are like terms. I can put those together. So I am going to go ahead and do that. 2x squared plus 1x squared is 3x squared. Positive x and negative x cancel each other out. We have minus 6 left over there. And that's all over my LCD. What I notice is I would try to do what Nicolette mentioned earlier and try to reduce this fraction. The issue right now is that the numerator isn't factored, so I need to do that. I'll take a 3 out. And there's that. Questions about this process? We're going to do it one more time all together, and then you're going to get one to try on your own. All right, one more time. I see my eyeballs go to the denominator right away. I'm like, oh, they're not the same. That stinks. So there's a little more to it. I would factor first. So I'm going to factor x squared minus 7x plus 6. It's going to be x minus 6, x minus 1. And then factors of negative 24 that make negative 2 would be negative 6 and positive 4. Then to find my LCD, I bring down the factors on the left, compare them with what's on the right, and the only thing I didn't write yet was x plus 4, so bring that down. I then rewrite my problem so that it has the LCD in it. I start by just writing it, you know, in its original form. So this is me just copying the problem right now. And then I use my eyeballs to help me insert the missing factors from the LCD. So this guy here is missing the factor of x plus 4. This guy over here is missing a factor of x minus 1. Woo. And now I'm going to go ahead and prepare to add by distributing my coefficients through. Distributing my x's through, I should say. So x times x is x squared plus 4x over my LCD. Bring down your plus. Distribute your x through. Bring across my LCD again. And now I have terms and a common denominator. Makes me pretty happy. I can go ahead and now combine my like terms. So we have an x squared here and an x squared over there. So I'll put those bad boys together. And then I have a negative x here and a positive 4x there. So I'll put those guys together because they have the same variable part. X squared plus x squared is 2x squared. Positive 4x and negative x is positive 3x. You'd have to leave your answer in factored form. That way you reduce it all the way. So take out your x. You're going to have 2x plus 3 over x minus 6, x plus 4, and x minus 1. I'm going to pause this thing. The only fraction you had to change for this one was the first one. Let's discuss. Okay, so step 1, I factored the denominators. So walk with me through your problem, will ya? I am. So I hear the question, where did the, oh. That's a copy error, -1, Mrs. Lucas. Who saw it first? It was... Unfortunately, my humanity shines through today. That's a game changer. It is a game changer. I got nervous because I saw David's and I was like, oh, mine doesn't match. Good call. I don't think I'm making D1 today. You're right. Busting chops. Okay. 9x plus 1. Let's discuss. Yeah, I think we're done, right? There's no factors of 1 that make 9, right? Let's dissect. Well, we're not solving. That's a good point to make. Yeah, like John's like, I want a quadratic formula. Yeah, but we only do that to solve for x. We will do that after we take our first test for this chapter. You will have to use this skill eventually to help you solve for x. So when you end up with a quadratic and you have to figure out what that number is to balance an equation, or to solve an equation rather, that's when you go to your quadratic formula. We're not there yet. We're not solving, we're just sort of simplifying and condensing. Okay, any other questions before you lovelies leave me today? I'll just